Our lesson today is fractions part 11, comparing fractions with like denominators. We have two fractions here, one on the left, 6/8, and 7/8 on the right. And the denominators are the bottom numbers of the fraction. And you can see that both of them are the same. Both of them are eighths. So when you're comparing fractions with the same denominators, it's really easy. Since they're both the same on the bottom, the only thing that we have to do is check the top number. And I can see on the left I have 6. On the right I have 7. 7 is greater. So we would read this as 6/8 is less than 7/8, using our strategy of just checking the like denominators on the bottom. And if they're the same, we can just compare the top. And you can see our fractions models on the top shows that here we're missing, 2 spaces, and here we have 1. So 7/8 is greater. Comparing fractions with like denominators is similar to apples to apples. For example, 2 apples here on the left side and 5 apples here on the right. Well, 5 is easy to tell that 5 is greater because they're apples. So fractions are the same. When it's the same denominator, you just have to check the top. Now, it's not like apples to oranges. When your fractions, the denominators are different on the bottom, you can't use that same rule, so that wouldn't work. So only think of it as apples to apples when you check your denominators. Steps are pretty easy. Just think apples to apples. When you're comparing fractions and you want to use the strategy of like denominators, just always take a quick look at the bottom. For example, here I see 8/12 and 5/12. 12ths and 12ths are the same. If they're the same, it's all we have to do is compare the top, and we're good to go. There's 3 outcomes. It could be equal, greater than, or less than. So we're the same, so we just check the top, and in this case, I see that 8 is greater than 5. So I put in my greater symbol, and this would be 8/12 is greater than 5/12. You cannot use this rule if the denominator is different. In that case, for example, if these were not both 12s, you would have to use another strategy. You may want to use cross multiplication or use models, but you could not use the like denominator strategy if your denominators are different. Okay, let's try some out. Pause it if you want. All right, let's try some. Compare the fractions, right? Greater than, less than, or equal to. 4/10 compared to 5/10. Apples to apples, right? 10 and 10. So I just have to look on the top, and I see that 5 is greater than 4. So this reads 4/10 is less than 5/10. 2/8 compared to 1/2. Do we have the same denominator? No, we don't. So therefore, we cannot use the strategy of like denominators. Now, we could use another strategy. Let's try cross multiplication. 8 times 1 is 8, and 2 times 2 is 4. When I compare the 4 and the 8, I can see that 8 is greater. So we would say 2/8 is less than 1/2. But here we could not use a like denominator strategy. We had to use another strategy. 3/6 compared to 1/6, apples to apples, right? 6 to 6. So we can just, because the denominators are the same, we can just compare the top. 3 is greater than 1. We would read this as 3/6 is greater than 1/6. 2/4 compared to 3/4, apples to apples, right? 4 and 4 are the same, which means that we just need to check our top, and I can see that 3 is greater than 2. So we would say that 2/4 is less than 3/4. 3/12 compared to 3/10. Can we use apples to apples here? No, we can't because we have different denominators. We have 12 and 10. We may not use our like denominator strategy. However, we could use a cross multiplication. 12 times 3, 36, and 10 times 3, 30. When we compare 30 and 36, we see that 36 is greater. And we would read this as 3/12 is less than 3/10. Last, 3/5 compared to 5/5. Apples to apples, yes, we can use our like denominator strategy. 3 compared to 5, and 5 is greater. And we would read this as 3/5 is less than 5/5. In review, our strategy today is comparing fractions with like denominators. First thing we do is when we compare our fractions left and right is to check the bottom number. If they have the same denominator, it means that we only have to check the top numbers and then draw our symbol for greater than, less than, or equal to. If it is not the same, you would need to use a different strategy. All right, thanks everybody.